right, in section 8-4, we start learning about trigonometry and the ratio of the lengths of two sides of a right triangle. Specifically, we are going to learn about the sine, cosine, and tangent. Now, we want to make sure first that the triangles that we are looking at all have right angles, okay? And when we see these labels here, sine R, cosine R, and tangent R, the R specifically stands for the angle measure of angle R, okay? Um, Also looking here, the lowercase letters represent the lengths of each side. So as an example, the sine of R is equal to the leg opposite of angle R over the hypotenuse. So if we look at the triangle in our picture here, we're looking at the measure of angle R, which is the area in here, and sine is the opposite over hypotenuse. So we're going to look at the leg that is opposite of angle R, which is lowercase r, and then the hypotenuse is this side right in here that is labeled as T. Remember, we got to remember that the hypotenuse is always straight across from the angle that measures 90 degrees. And in this case, angle T measures 90 degrees. So the side that is directly across, which is T, is going to be your hypotenuse always. Okay. So we have all of these, and it gives us which sides we're going to use for each one for our sine, cosine, and our tangent. One thing that we have to remember and that the book gives us is something called SOH CAH TOA. Okay, and this will help us remember what sides we use with each one of these ratios. Sine is the opposite over the hypotenuse. Cosine is the adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg. Okay, and adjacent just means it's directly connected to the angle. So as an example, the cosine here is adjacent over hypotenuse. So if we look at angle R specifically, adjacent, the side that is directly connected or adjacent to angle R is this S right here, okay? And then the hypotenuse, of course, again, is this T side over here. Let's go ahead and look at problem number 1. Okay, and for each one of these, we want to find the sine of J, cosine of J, tangent of J, and then the sine of L, cosine of L, and the tangent of L. And then we're going to express each ratio as a fraction and add as a decimal to the nearest hundredth if necessary. Okay, so we'll start off with sine of J. Okay, if we remember from our phrase, SOH CAH TOA, sine is opposite over hypotenuse. And we're looking at angle J. Okay, so angle J here. Opposite would be this side here, so 12 over hypotenuse. Here's our 90-degree angle, so this would be our hypotenuse here, 12 over 20. Okay, and then we can stick that into our calculator to figure out our decimal. 12 over 20 gives us 0.6. Next is cosine of J. CAH is adjacent over hypotenuse, so we look at J. The side that is connected to J would be 16 over hypotenuse is 20. Stick that into our calculator. Gives us 0.8. And then we have the tangent of J. TOA is opposite over adjacent. Okay, so we look at J, our opposite is 12, and our adjacent is 16. We stick that into our calculator. That gives us 0.75. Okay. The next step is to find the sine, cosine, and tangent of L. So we'll put that here, sine of L. So is opposite over hypotenuse. So we look at angle L. The opposite side is 16. The hypotenuse is still 20. (16 over 20) gives us 0.8. The cosine of L, CA, is adjacent over hypotenuse. So if we look at L, the adjacent side would be this 12 here. It's the one connected to the angle. And then the hypotenuse is still 20. 12 over 20 gives us 0.6. And then the tangent of L, TOA, opposite over adjacent. If we look at L, the opposite is 16 and the adjacent is 12. So we do 16 over 12 and we put that into our calculator. (16 over 12) gives us 1.33. So we're doing an approximate down here, approximate 1.33, and that is all for that problem. Let's go on to number 2. Again, we're still looking for the sine, cosine, and tangent of J and L. So we'll do the sine of J. We look at J. So is opposite over hypotenuse. So here's the opposite. Your hypotenuse is directly across from your 90-degree angle. 24 over 40. We'll stick that into our calculator. That gives us 0.6. Cosine, CA, adjacent over hypotenuse. This would be the adjacent side, 32 over your hypotenuse is 40. Put that into calculator. Gives you 0.8. Tangent, TOA, opposite over adjacent. Should be putting J in there. Opposite is 24. Adjacent is 32. 24 over 32 gives you 0.75. Go on to the sine of L. We look at L. Opposite is 32 and hypotenuse is 40. We know 32 over 40 gives us 0.8. The cosine of L, that's adjacent over hypotenuse. So 24 over 40. We know that is 0.6. And then finally we have tangent, which is opposite over adjacent, the tangent of L. The opposite is 32 and the adjacent is 24. And we haven't done that one yet, so we'll go ahead and stick that into our calculator. 32 over 24 gives you approximately 1.33. Approximately 1.33. Approximate is that little squiggle in there. Number 3. The sine of j, looking at j, opposite over hypotenuse, gives us 36 over 24 square roots of 3. 36 over 24 square roots of 3. Don't forget, you see my first mistake in the top one up here? I didn't put my parentheses, so it gave me a 2.59. You have to make sure that when you're sticking this into the calculator, you put your parentheses around the bottom denominator. Okay, so 36 divided by parentheses 24 square roots of 3, and it gives you approximately 0.87. Okay, the next one is the cosine of j. That's adjacent over hypotenuse. So if we look at j, the adjacent is 12 square roots of 3. Over the hypotenuse is 24 square roots of 3. Square roots of 3. And I'm going to push this arrow over to get rid of the square root. Okay, and put that in parentheses, divided by, oh, that should have been a 12, sorry. 12 square roots of 3 divided by 24 square roots of 3, arrow over, and that should come out to 0.5. The tangent of j, opposite over adjacent, so we have 36 over 12 square roots of 3. 36 over 12 square roots of 3. That gives you approximately 1.73. Repeat with the angle L. The sine of L is the opposite over hypotenuse, so 12 square roots of 3 over 24 square roots of 3. We already know that. It is 0.5. Cosine of L is equal to adjacent over hypotenuse. Adjacent is this 36. Hypotenuse is 24 square roots of 3. We know that it is approximately 0.87. And then finally we have the tangent of L, which is opposite over adjacent. Opposite is 12 square roots of 3 over the adjacent, which is 36. 12 square roots of 3 divided by 36 gives you approximately 0.58.